I'm at the high school right now, and I need your help. Could you provide me directions to get to the middle school? What do you think? Do you think you could provide me directions to the middle school? Some of you can, some of you can't. Okay. What did I tell you? Where did I tell you I'm starting? The high school. I gave you that. I'm giving you that true piece. That's what's called a given. Where do I need to end up? Middle school. That's where we end up with. How are you going to get me that? What's in the middle? What you guys know of Delmar. The streets of Delmar, right? The hard-hitting streets of Delmar. Everyone agree? That's what a proof is. A proof is a big puzzle that you got to put the pieces together, where I will give you something to start with, aka I'm starting at the high school, and then I will ask you to prove something's true. Get me to the middle school. How are you going to connect what I give you to what I'm asking you to prove is true? How are you going to connect those? With all the geometry vocab that you know. And you've got to put it in the right order, like a puzzle. That's what a proof is. A big puzzle that we need to put together in order. All right? Okay, so I'm going to give you a couple pieces that'll help you put this in order. All right, because you guys may know every vocabulary term down cold. Bad news, it's not good enough. So I'm going to give you 3 more things that could help you connect what I give you to what I'm asking you to prove. Number 1 is what's called the reflexive property. Now, you guys read that, you're going to be like, is this guy for real? Go ahead, read through that, right? Reflexive property. A quantity is equal to itself. Oh, thanks for the update, Mr. Carlino, right? Segment AB is the same length as segment AB. Shocker! Huh? Shocker. And angle B is the same measure as angle B. Nobody's impressed yet, huh? Me neither. And you will be. Why would I ever use that? You will see at the end of class today. I'd like you to turn your attention to the board to the right. Any one of these we go over, I'm going to post up on the board. So you'll see reflexive is up there. I will give you all these on the test after Columbus Day. The test that we have scheduled after Columbus Day weekend, I will provide all these on a sheet of paper. Just the names, that's it. Not how they're used, just the names. All right, so that's reflexive. We'll get back to that in the class and how we can use that to benefit us. Next, substitution. You guys have done this in algebra before. I believe. Back in the day, you guys had something like x squared minus x over 2 plus 3y. And then maybe the teacher said, hey, kids, x equals 4 and y equals negative 2. What'd you do to figure out what this was equal to? What'd you do with the 4? Everywhere you saw an x, you plugged in 4, right? Substitute. And everywhere you saw a y, what did you do? You substituted in. We can also do that in geometry. Take a look at my example underneath substitution. We can also do this in geometry. All right, so I got some line segment AB, and it's equal to twice the length of AD. All right, so I got some line segment AB, it's equal to twice the line segment of AD. Right below it, I'm also going to tell you that AD and DB have the same length. From those two, ready? I'm going to start challenging you right now. From those two givens, can you write a true statement using substitution now? Okay? AB is equal to twice AD, but AD is also equal to DB. Do you think you could provide me with a true statement? Try to write it down right now, number 2, using substitution in those two. What else must be true then, using those two? Don't create a new line segment. I'm asking you to substitute in now. Look at those two. AD equals DB. So what else must be true? Anybody want to chime in? Something true here? Callum, go ahead.
AB is equal to AD plus DB.
Where are we? Well, I'm not on the angles one yet. Did you tell me this one?
Yeah.
Oh, sorry. I must have misheard you. Go ahead. AB equals?
AB equals AD plus DB.
Okay, I didn't want you to. There's no addition, though. Because so I don't want to substitute. I'm just substituting in. Okay, I'm not trying to add anything. Okay? Everybody, AD is equal to what? DB. Yeah. Oh, easy, Jackson. Go ahead.
AB is equal to 2DB.
2. Where did he come up with that statement? Take a look. AD was equal to what? DB. So wherever he saw an AD, he plugged in DB and rewrote it. Substitution. All good? You are correct, Callum. It's just not by substitution. Okay? All good. All right, let's keep going. One doesn't make you great. Take a look at the next one. I got angle A and B equal to 90. A is equal to C. B is equal to D. Can you come up with 2 correct statements using substitution and those 3 now? Can you? Substitute in and give me a true statement. Maybe you can give me 1, but can you give me 2 true statements? Just substitute in. Wherever I see this angle, I'm going to substitute in the new angle. Let me start talking to you here. Yeah, got anything for me? One true statement only.
Angle C plus angle D equals 90.
Okay, I like it. So what Via did was, all right, A is equal to C, so I'm going to take C, plug it in for A. So we got the measure of angle C plus, and then Via took B is equal to D, so I'll plug that in for B. And both of them are equal to 90. Great job. There's one. Good job. There should be more. Okay? Actually, more than just one. There's actually multiple things we could do here. You got another I could substitute in for. Maybe Via just substituted in twice. Maybe you could just substitute in once now and get something different. 2-4. Romeo, got anything, boss?
I have angle A plus angle D equals 90.
Good. Angle A. He kept angle A. Then he substituted in D for angle B. And those are equal to 90. Good job. Are there others? Absolutely. Okay, there's others using substitution. Yes, Scott, go ahead.
Could you do 90, then you subtract?
Don't get subtraction in here. Because hey, here he goes. This is why, Scott. What's the reason? Substitution, right? Once you start subtracting, then it becomes subtraction and not substitution. Okay, so I just want sole substitution. Everyone good? You good here, boss?
Yep.
Great. Everyone else all right? So I got reflexive, which I guess we kind of, we understand now. Substitution. All right, last one for today, and this is the big one. Addition postulate. Addition. So here's what addition says. Let's do this visually first. A equals B. So what I want you to do right now is do 2 line segments for me that look about the same length. Just freehand it. 2 line segments that look about the same length. Call one of those line segments A and the other one B. And then it says C equals D. So I want you to do another pair of line segments, a little longer than A and B, but also about the same length. And call those C and D. So this pair is equal, and this pair is equal. Here's what addition is saying. Everyone, take line segment A and visually in your head put it together with line segment C. So A and C, boom, coming together to form a new one. Everyone's got that in their mind, A and C. Now take B and D, put them together to get a new line segment. What do you know about my 2 new line segments, my 2 new ones? If I took A and C, put them together, B and D, put them together, what do you know about those new segments? What should you know, Josh? They should be equal in length, congruent. Everyone agree? Yeah? Okay, what if I took A and D, put them together, and then put B and C together? They're still congruent. Everyone agrees? Why are they congruent? Because of this addition. All right, this new one called addition postulate. I don't care if you know postulate or not, it's addition. Here's what it says. How many pairs of equal quantities do I have up there? How many pairs? 2, right? If you put them together, the results are equal. Okay? If you put 2 pairs of equals together, the results are equal. Everyone see that? Are you good? Okay, how do I write that now? You tell me, which ones could we put together again? A plus C is the same equal to, if I put what together? B and D. That's what addition says. Yeah?
Shouldn't there be a congruent sign on top?
No, doesn't need, we're talking length, so not right now. Okay? Good question though. Or, and I'm going to put an or here. Because isn't there something else that could be true using addition? I could do A plus D, and that would be the same length as C plus B. Yes, good job, everybody. So you're picking this up. But again, how many pairs of equal quantities did I start with? How many pairs of line segments? 2. You got to have 2 if you want to add. Okay, you got to have 2 pairs if you want to add. Everyone all right? Okay, huge moment right now for you. Huge moment. Take a deep breath here. You're about to do your first proof of the year. This is a big, not just moment of the year. This is like big moment mathematical career. I'm talking K through 12 right now. All right, this is huge. All right, this is huge right now. All right. First, let me show you how a proof is set up. I'm going to give you true information. I prefer, if you can, mark it on your diagram right away. So AB equals DE. Put your hash marks on it. AB and DE are the same length. So are BC and EF. So what should I put on those? I don't want to put singles on those. Put little doubles. Good. BC and EF. I'm telling you that's true. Here's what I need from you. Why in the world would AC and DF then be true? Okay? This is called your proof statement. Using your givens, why is this true? This, everyone, this proof statement should be the last line, my last statement in my proof. Okay? How do we get there? Using our knowledge of some connectors here. Reflexive, substitution, addition. Okay, that's how we're going to get there. All right, I don't know how many statements it's going to be. All right, but I need to start with what I'm given and somehow show me that AC and DF are the same length. All right? So here we go. Look at what you're given. What do I need to do to these two to get to AC? Because that's in the proof statement, AC. So what do I need to do to these two to get to AC? Go ahead, what do I need to do? Everyone agrees, right? I need to add them? Okay, whoa, time out. What do I need to do to DE and EF to get to the longer one, DF? I got to add them up again. So does everyone see this is going to be addition somehow? Okay, whoa. Before we do addition, I just told you I was standing right over here about a minute and a half ago. How many pairs of equal quantities do you need to be allowed to add? How many did I provide in the givens? So we can add them now. Okay? You need to tell me what we're adding together, though. Whoa, hold on. Go ahead, Via. Give me a pair we're going to add together. AB plus BC, everyone all right, is the same equal to, if I added what other pair? DE plus EF. Good. Does everyone agree with that statement? Everyone agrees with that? Okay, now, why is that statement true? What gives me the right to write that? Addition. You can write postulate if you want to impress people, but addition. Is that what I asked you to prove, though? No. I asked you to prove AC and DF. Statement 2 doesn't say AC equals DF. All right, so we got to keep grinding. AB plus BC, rename that. AB plus BC, rename that. What else can I put in place of that instead? AB plus BC is another name for? Okay. So AC is going to go in place of that now. Everyone see that? I'm putting that in place. Equals, what could I put in place of DE plus EF? DF. Anybody know why? The reason why here, that I just replaced it and plugged it in. That's substitution. Everyone see, I substituted in AC for AB plus BC. Is that what I was asked to prove? And do you see that's always your last statement in your proof? Always should be, is your proof statement. Okay? Take a look at that, soak it in. It's a fourth period. Everyone's all right? We sure? Okay, I told you this was a big moment, right? K through 12, you just did your first proof. So there has to be a little celebration involved as well. Rows 1 and 2, go ahead. If you got your phones, go grab it. Grab your phones. Rows 1 and 2, run and 2. Relax, 1 and 2, go grab your phones. Relax. Actually, you're right, I guess. Rows going this way. I should have said columns 1 and 2. You would have been fine. Because that's what I always refer to them as, columns. Okay, rest of you guys, if you got your phones, grab them. All right, we need to signify this moment in your mathematical career. So you got your phones, you got your first proof in front of you. Go ahead, take a little selfie with it. All right, you can post it to all your social media. If you want to gather a couple of your friends around here, take a quick selfie with your first proof ever. Go right ahead. You guys got 2 minutes to do whatever you got to do. Okay, 2 minutes. It's a big moment. Congrats on your first proof. Way to get through it. Bad news now, this is one of, I can't even tell you how many we're going to be doing this year. All right, I don't even want to put a number on it to scare you. So here, again, the basic setup of a proof. I'll give you information. You use those devices to hopefully get to why the proof statement's correct. And enjoy this when you can, that it's only 3 steps. All right, because they do get longer the more information I give you. Okay, because those aren't the only yellow ones that'll be up there. All right, that board will be filled by the end of this unit. Okay. All right, one doesn't make you great. Let's go on to a second one now. This dealt with segments. Let's talk about angles now. Can I do the same thing I just did with segments for angles? And the answer is yes. I get a little concerned with this though. Do you know how to find these angles? So ADF is equal to CBE. How do I mark angles equal? How do I mark angles equal? Arc marks, let's go. And I hate to do this, but I'm going to walk around making sure you know where those angles are. So A to D to F, or A to D, yeah, ADF. Do I have that right? Yeah, I got it. I'm looking backwards. A to D to F equal to CBE. Find those angles, mark them with arc marks, please. Trace it with your finger, your pencil, your pen, so you can find those angles. ADF and CBE should have arc marks on them. Again, I'm just doing this to make sure we're good. ADF, CBE. Okay, CBE. What angle did that form? That one shows CBE. Okay. That's good. Gotta crawl before you walk. Read all the letters. Ready? Where's A? to D to F. You just traced out an angle. Where was it? ADF. ADF. Okay. And then, so mark that with an arc mark. And then CBE. Where's that angle? There you go. Mark it with another arc mark. No, you didn't tell me there. You told me here. C to B to E. A, ready? Follow with me. A, B, F. See that middle letter? That's where the angle's going to be.
Oh.
Right? So where's it going to be? Good. And where's C to B to E? There you go. Good. Get the other one. Okay, we're good. Nice job, everybody. We're all on the same page now. So A to D to F right here. C to B to E right here. So those are the two right there. Now I gave you another pair, didn't I? Now how should I mark those on my diagram? I don't want to do a single one because not all four are equal. Do doubles. Ready? EDC. E. I already marked those myself, huh? No. E, D. There it is. E to D to C. Bottom line, if you're struggling, find the angles. Remember, the middle letter always tells you where they are. E, D, C. So mark it at D. A, B, F. Mark it at B. There you go. There are the two. All right. Well, why don't we start two? I didn't do this for you here. I did it for on the last one. What's always your first statement? You're given. So why don't we plop those in right now? Angle ADF equals angle CBE, and EDC equals ABF. Given. Now look at what I'm asking you to prove is equal. Angle ADC, find it, everybody. Find angle ADC for me. A to D to C. It's the big one, right? It's the bigger one right here. A to D. Oh boy. I don't want to do that. Here we go. A to D to C right here. Prove that angle is equal to ABC. Find it. Where's ABC? A to B to C. This one right there. So how can I show those two angles are equal? Well, look at the two angles you marked right here. What can I do with those two to get to the big one, ADC? What can I do, guys? Put them together, add them. And then, hey, is it the same thing for the other pair up here? Add them. All right, whoa, you keep saying add to me. You keep saying add. But the only way I can add is if I have how many pairs of equal quantities? Two. How many are right in the givens? Okay, so we can add. Because that answer may not be two every time. All right, so we can add them together. Now, step two, you have to tell me what you're adding. So let me start. You're going to take angle ADF and add it to angle ADF. What should I add that to? Get my numbers here. Go ahead. 2, 3. Lucy. Not here. All right. Let's try George. What do I have to have ADF added to?
EDC.
EDC. So ADF plus angle EDC is the same as if I added, here we go, what other pair of angles together? 2, 1. Scott, what other two angles added together equal the same as ADF and EDC?
CBE and then angle ADF.
Good. CBE plus angle ABF. Why can I write them like that? Addition, yep. That's what you're doing. You're adding, so. Is that what I asked you to prove, though? So don't leave it like that. What's the same as saying ADF and EDC added up? That's angle what? ADC. Equal to, what's the same? What could I plug in for CBE and ABF? ABC, yep. And that's not addition. What did I just do there? I substituted in something equal to it. So I wanted to show you it can be done with segments and how addition can be done with angles. Now I'm really going to flip the script on you. Any questions? Because right now you guys just think these proofs are given, addition, substitution. No, no, no. Are you ready for the last one? Here we go. Given DE equals BF. Mark it. Mark it. With what? What are you marking them with? Segments. Hash marks. DE and BF. That's it. That's all I gave you. So let's put it in our givens now too. Ooh, how are we doing this, huh? How am I going to go from DE to DF? DF being equal to BE. Ooh. Huh? Wow. All right, well, let me ask you a few questions to kickstart you here. I know DE and BF are equal. How do I go from DE to DF on that diagram? How do I go from DE to DF? What do I need to do there? How do I get there? Zach, how do I get there?
You add EF.
Don't I add on EF and I could get there? Does everyone agree? Take DE and add on what again?
EF.
Okay, hold that thought. What about on this other side? How do I go from BF to BE? How do I go from BF to BE? Add what? EF or FE, right? What you keep saying add, don't you? So I'm going to ask you my usual question. Are you allowed to add here? How many pairs of quantities do you need? 2. How many did I write in the givens?
1.
Only 1. You need to come. Where's the other pair that I'm going to add, right? Because you need 2 to write addition. I'm not ready to add yet. But you guys kept telling me what line segment do I need to add to both of them? EF. And what do you know about EF and EF? Aren't they equal to each other? Yeah, that's where that weird reflexive comes into play, when you don't have a second quantity to add. So again, what line segment am I adding to both? EF equals EF. Why is that true? Reflexive. That's where I'm going to start using that, when you need another quantity to add. If you already have 2, just go and add. You don't need reflexive. But if I only gave you 1, like I did in this situation, what you need to add on is going to be by reflexive. All right, now how many do I have listed? How many pairs do I have listed now? 2. Can I add now? Can I add them? Yep, ready? DE plus EF is the same as if I added what? BF plus EF. And this is by what reason? Addition, yeah. I can add now. Now you have 2 quantities. Got to have 2, though. Is that my proof statement, though? Nope. What's DE plus EF the same thing as? DF, substitute it in. And what's BF plus EF the same thing as? BE. By substitution. So sometimes you might have to add in your own equal quantity before you add. Just remember, how many do you need before you add? How many quantities? 2. Go to your homework real quick. I'm not ready to pack it up. I want to make sure we're good. Okay, numbers 1 through 4. You're just writing down the property, no proof. Okay, you're writing down the property that's being used. Once you start getting to 5, see how it says write a formal proof? That's statements and reasons. Okay, that's statements and reasons, starting with number 5. Hey, and I'm going to tell you, it's not all addition. Okay, I can tell you 5, 6, 5 and 6 are an addition. Okay, it might be 2 steps. All right, it might be just given substitution and you're done. Might be given addition substitution. Given reflexive addition substitution. All right, don't assume it's always 3 steps. All right, could be 2, 3, or 4 now. All right, so we'll see what you can do with this tonight. But don't use subtraction, don't make stuff up. Stick with reflexive, substitution, and addition tonight. Okay, that's where your lane is. All right, don't move out of it. So once you get to number 5, now you're doing your statements, reasons. And you don't have to put addition into everything.